Okay, lovely to see you. I am, I'm going to say again what I said the other day, yesterday. If this is going to be an unnecessary distraction, then you're completely welcome to drop out. I think what I can't have is people sort of batting in and out. You've either got to go for it or not go for it, and after a couple of weeks, you'll probably get a good feel for whether it is for you. And I hope it's good to have conversations with a few people who've already had a little look at what their sort of potential future pathway might require. And of course, who knows? Some of you, you may have no idea what you want to do. So it's you can keep your options open. But let me talk about the content of Further Maths very briefly. Then we'll actually do some work. And I'm going to email you all at the end of this a copy of the specification, which I'm not a huge fan of doing, to be honest, because they're so wordy and complicated, but you've got it. Some of you might want to go through and see what it is we're going to cover. A copy of the textbook, because we haven't got any physical textbooks, so it's all going to have to be electronic. Have you been set up on Active Teach? So I can make sure it's available to you on Active Teach as well, which is better actually because you get the answers automatically then. The third thing that's in the email I'm going to send you is a link to the solution banks, which are the worked solutions that go with the textbook. So that's what the email will contain. AS Further Maths contains two main chunks. The first part is the bit that everyone does, and that's called Core Pure, and that's what we're going to start today. So that includes complex numbers that we're going to start with today, but also some proofs, some matrices. We've never come across matrices before, some algebra and function stuff. Calculus is a branch of maths that you'll become very familiar with, and vectors. And if you go on to do the qualification, you're going to do one exam that's an hour and 40 minutes long that covers that. And that's half, so we're going to make sure that we get through that as quickly as we can. And then the second paper, the second half, is made up of two options, and we have to choose one of these combinations. Now, it seems to me that as a number of you are thinking physics, we need to do a combination that includes the further mechanics section. But I'm undecided as to what else I will do. So, for example, if lots of you want to do computer science, then the decision maths is worth doing, so I'm sure mechanics and decision maths is an option. There we go. Decision maths is about algorithms. However, if lots of you are thinking about doing straight maths, it might be this is a better option. And if some of you are thinking about doing psychology and anything else which is statistical, it might be we end up doing statistics and mechanics. I don't know. So we're definitely going to do the further mechanics. Well, we shall see. We shall see. I had thought we'd get through the Core Pure by Christmas, and then we'd do the options after Christmas. But actually, because the Core Pure assumes you've done straight A level, so for example, you can't really do further calculus until you've done the normal calculus, we might have to just be a bit smart about how we time it. I can remember teaching back in the day when we did do further maths, A-level students who were doing further maths, and it was always a bit frustrating because you'd come to teach something and they'd already done it in further maths, so I'm going to try and avoid that. Right, so here's what I'd like you to do to start with. We're going to start with the aspect of maths called complex numbers. And some of you will have watched the little video series that I sent out in the summer, so you'll be a little bit ahead of the game, but I don't think there's any harm in starting with basics. So what I'd like you to do is I know you've got calculators that will solve these for you, but what I want you to do is to use the quadratic equation formula to solve these three quadratic equations, okay? So you're going to use the quadratic equation formula to solve those three equations, and if you've forgotten what the quadratic equation formula looks like, it looks like that. leave the answer in surd form if that's needed. So we have here the three flavours of quadratic equation that we've come across before. This is a usual quadratic equation that's got two solutions, you know, we end up with 4 and minus 2. But we know they're not nice round numbers, so they're in surd form. Here we end up with a square root that's negative, which we can't do, so that's got no solutions. And here we get one solution. And of course it's all to do with what you find here. So that thing underneath the square root sign is known as the discriminant, because it discriminates between equations that have two solutions, one solution, and no solutions. So we can say, right, if b squared minus 4ac is positive, we get two solutions. They're often referred to as roots. If b squared minus 4ac is 0, as it was in the third example, that's when you get just one solution, because there's nothing underneath the square root sign. So that's one root. Sometimes that's called a repeated root, because actually you get the same answer whether you do the plus or the minus. 2 plus 0 divided by 2 and 2 minus 0 divided by 2. And if it's negative, we get 0 roots. And at A level, that is where you will stick. But actually, sometimes in this situation here, we need to solve these equations. We can't just say there are no solutions. And so we do something a little bit like we did, the Egyptians did when they were working out things to do with circles, where they realised that the ratio between the circumference of the circle and its diameter wasn't a number they were ever going to be able to write down accurately, so they called it something, they called it pi. It's not exactly like that, but it's sort of like that. What we do is this, we say, okay, there aren't any real numbers here, so we say there are no real roots. So what we do is we come up with this pretend imaginary number, which helps us to sort of get an answer. What we do is this, we say, okay, the square root of minus 28, I know I can write that as the square root of 28 times the square root of minus 1. And the square root of minus 1, that's my problem, isn't it? You can't square root a negative number. So we solve that problem in a typical maths way. We just say, okay, I'm going to call the square root of -1 something. I'll call it I because it's imaginary. It's not a real number, it's imaginary. This is different to irrational, this is imaginary. So what we say is that the answer to this question is 2 plus or minus the square root of 28 times I divided by 2. It's important you realise the I isn't underneath the square root sign. And the square root of 28, I can simplify, can't I? Because it's 4 times 7, and I know what the square root of 4 is. So actually that becomes 2 plus or minus 2 root 7 times I. Are we happy with that? That's sort of GCSE, isn't it? Square root of 28 is the square root of 4 times square root of 7. And so my answers are, because I can divide everything by 2 now, 1 plus or minus root 7I. Those aren't real answers. You know, this is not a real thing. It is an imaginary answer, but it is an answer that allows us to go on and do other stuff, and doing other stuff is what we're going to do. So we call equations where the solution involves the square root of -1. We call problems that relate to that complex numbers. And often they're referred to as imaginary numbers. They mean the same thing. And they all revolve around this substitution, replacing the square root of 1 with I, which says, okay, we haven't got any real roots, but we do have imaginary roots. Now let's see how our calculators deal with this, because you're never going to have to solve a quadratic equation in A-level maths, and I'm hoping you already know how to solve them. So have you got your calculators? Oh yeah. Or if you haven't, so have you been through this, how to solve quadratic equations in a calculator? So you go to equation mode. Don't use the solver. The solver is a misleading thing I never use. Instead you go to poly, and degree is 2 because we're solving a quadratic. The order of the equation is 2. And so let's try and get it to solve the one that had imaginary answers. This one here. So x squared minus 2x plus 8. So I do 1x squared minus 2x plus 8. And I'm assuming that's what your calculator says at the moment, yeah? Unless you do this. Shift, set up, oh sorry. And if you go down here to complex mode, and you choose the A plus BI option, and now you do it, it gives you the two answers. 1 plus root 7 and, sorry, 1 plus root 7i and 1 minus root 7i. You'll see this rather annoying thing it does here. Always look down here. This is where the real action is. So you've got those two answers. 1 minus root 7i, 1 plus root 7i. Has everyone managed to get into that mode? Yeah. So exit, shift, and then go down to complex mode and choose the middle one. That's it, set out there, yeah, and then press exit, and then press exit, and you're there. Is it working for you? No, see? Yeah. Good, excellent, excellent. Right. Now you'll never need to do that at A-level maths because complex numbers don't feature at A-level maths at all. So just very quickly, and then you can check it on your calculator, but do it manually first. Can I get you to solve another one which has an imaginary answer? So that is x squared minus 6x plus 18 equals 0. I think, yes, that's it. So when you hit the minus 36 underneath the square root sign, we'd normally say, right, that's it, I'm out. We no longer do. We now say, oh, actually, that's the square root of 36 times the square root of 1, or 6i. So you end up with 6 plus or minus 6i over 2, which is 3 plus or minus 3i. And I is not like pi. Pi is just us writing a number that does exist but can never be written accurately with a symbol. I, remember, isn't like that, and in the same way as it's not like a square root, but we can manipulate it and do the sorts of things that we often do with pi and with surds. We can do the same thing with these complex numbers, these imaginary numbers. Those two terms are interchangeable. So when you get your PDF by email, or when I manage to set you up on Active Teach. This is the Core Pure textbook, remember, so this is half of the course, the other part will be those two options that we have chosen. So, because we can't do anything like enough practice, my proposal is that you have a go at question 2 on page 3, where you've got to line those up, so turn them into proper quadratic equations. It's z rather than x, but it doesn't really matter. And it's showing you that, you know, we're expecting all of these to have imaginary answers. And then question 3 on page 5, probably a little bit easier. You can do the same. So question 6, I'm going to put a little star by it, because that's a sort of non-straight. Oh. Question 6 is really good. I can't show it to you though, apparently. Question 6 is about, is that going to be big enough? Yeah, it's a missing value question. So you've got a quadratic equation, but we don't know how many z's, we don't know what b is, it's called b, but we're told it's got non-real complex roots. So what we're being told there is that the thing under the square root sign needs to be negative. So what you need to work out is what range of. So I thought I might revisit that question when I see you next on Monday. That's some practice at solving, okay? Some practice at solving. We haven't got any more time to do that now. But that's really what this is about. Complex numbers are about solving equations which don't have real solutions. Let's move on. What else can we do then? Well, we can simplify expressions involving complex numbers. So let's go back. So we're sort of going back a little bit, if you like. What's going on? Bad gateway. Bad gateway. Right, okay. We'll give up with that. I've got my PDF here, so let's just, sorry. Really slick, Cooper, really slick. Here we go. Right, sorry. So let's look at what we can do with these square roots of negative numbers, how we can simplify them. So here we've got one imaginary complex number, 2 plus 5i, and we're adding another complex imaginary number, 7 plus 3i. To simplify them, it really is as straightforward as saying, right, I've got 2 plus 7, so that's 9, and I've got 5i plus 3i, so that's 8i. It really is as simple as that. And similarly, subtracting, just got to make sure that the big alarm bells are going. We're taking away both of these things. So I've got 2 take away 5, so that's minus 3. And I've got minus 5 minus 11, which is minus 5 plus 11, so that gives me minus 3 plus 6i. And this is just 10 plus 16i, simple as that. And this is 5 plus 3i. Simple as that. Yes?
It's just like replacive of x.
Absolutely. Absolutely. So you can easily simplify expressions involving imaginary numbers in the same way, you're absolutely right, Rory, as x. So we're not going to do any more practice out now, but I'll add a little bit of practice to your practice list. So 3, 4 and 6 are definitely worth having a go at. So what I want to get to is multiplying, which is a little bit more involved. So let's see if I can find that. Okay. So if I want to multiply one complex number by another, let's just see how we do that. And Rory, you're absolutely right. We start off by just pretending it's x, but there's one nice little twist. So go on, just see if you can grid out those two expressions. So Bill, I don't know if you're used to when you multiply at double brackets going like this, or do you do it a different way?
I do it the way where you just like add the lines.
Whatever floats your boat. Yeah, let's go for it. I'm a grid man. There's one little twist which I want to point out. And I'm just going to remind you that the square root of minus 1 is what I is. So I don't know if you've spotted what's going on here. I squared is just minus 1. I squared is just minus 1. So what I've actually got here is minus 15. I've actually got minus 15. And so we know what we can do. Double peanut. So we've got that, and we've got that. And because of the way we write complex numbers, we put our whole number bit first, our real bit first. So we've got 8, take away 15, and then we've got, do you just want to have a quick check of that one if you haven't got that one? So because I squared is minus 1, this actually is 16 times minus 1, which is minus 16. So double clean up there to give us 33. And then we double clean up here to give us minus 56i. And so multiplying surds together is a key skill, and you'll find some practice of that on page 6 of the textbook that I'm going to send you. Active Teach, once I manage to get you set up on Active Teach with this textbook, that makes it a whole lot easier. But until then, so you'll just get a PDF. So you can hopefully find, I'm assuming the page numbers in the PDF are wrong because of all the pages at the bottom. But if you look at the bottom of the page, you'll see the page numbers. So hopefully you've got a page number down here somewhere. There you go, page 6. So we're on the right page. So you've got your questions there. If you want the answers, so the answers, I've sent you a link in that email. The answers are on Physics and Maths Tutor, where you can pay Dominic £40. Absolutely, yeah. So we are doing complex numbers, so the answers are here. So it's a little bit fiddly. We've got to work out which exercise we're on, and so this is exercise 1C. So you'll find the answers are there. Once it's on Active Teach, once we've got Active Teaching up, it'll all be good. Right. Okay. Let's do another little puzzle then to do with multiplying. So if, come on, there we go. Just says simplify. So, how else can you write these things? How else can you write these things? So that first one we can just write as minus I. Minus I. And the middle one is just 1. The middle one is just 1. And then the one at the end, well, I've got 2 to the power of 5, so that's 2, 4, 8, 6, 32. 32. I to the power of 5. Now, you know, using a similar approach here, I to the power of 5 is I times I times I times I times I. So we end up with 32I. And we're quite quickly away from what this is all about. Remember what this is all about. This is all about writing an answer to equations which previously haven't had an answer. We've said as soon as we hit the minus sign under the square root sign, no, that's it, we're out. So we're now just manipulating these answers without really, you know, it's quite easy to forget that that's where they originally came from. But no, they very much come from solving these equations which have hitherto been unsolved. And I guess here we begin to see why I is useful, because every now and then it disappears. Just like we rationalise expressions with surds sometimes. The surds disappear. Well, that's sometimes they disappear. Sometimes they don't. And so we need ways of describing and representing complex numbers, and that's all very much part of the syllabus. Now, I am not going to mark the work you do for this, all right? So between now and Monday, it would be really good if you could have looked through and done as much of this as you possibly can. I am going to have a look at this question. So I'm going to start next on Monday with this question here. But you know, this is all very much down to you. This is driven by you. If you have the time to do it, that's good. If you don't have the time to do it, and you know, and I'm not going to judge you at all if you decide it's just too much for you. You know, if you haven't got the time to do it, you're probably wasting your time. You know, and I need to be completely honest with you. I'm not saying any of you are not of the calibre for it, but it's just, you know, you've got to make sure that you're honest with yourself. So yeah, have a go at that, and then we'll move on. I'm going to have to move at a much faster pace than I would normally, because we've only got a little bit of sort of lesson time at our disposal each week. So you're going to have to be able to, in order to be successful here, you're going to have to be able to commit. Some of you won't enter the exam. You'll just be able to say on your personal statement and in interviews that my school didn't offer further maths, and therefore I worked through further maths on my own with the help of one of my own teachers. Okay? So that's the wording you're going to use, because you know, we want to make sure you're not disadvantaged. Some of you will take the exam, and I'm absolutely, you know, we're going to get through the syllabus in time. I'm absolutely certain we will. I don't want to do that if you haven't got if you don't look like you're going to get an A, because you've got to fess up. If you've done an exam, you have to say what you got in it. So some of you will do the exam, and yeah, there are courses that will reward you for that as well. So there we go.